In this video, we're going to be solving some linear equations. So, for example, in the following ones, we're going to be solving for x or for whatever pronumeral we see in the equation. So in this case, we see the only pronumeral is x, so let's see what we can do. We can expand the right-hand side, so that's going to be 2x plus 6 equals to 11. Now we can subtract 6 from both sides, so that's going to be 2x equals to 5. And now we can divide both sides by 2, so that becomes x equals to 5 on 2. Or we can express it as 2.5. For the next one, we're going to have, we can expand the left-hand side first, so that's going to become 4x minus 4 plus x equals to 1. And then from here, what we can do is we can add the two x's together. We can add a 4 to both sides to get rid of it on this side. So that's going to become 1 plus 4 is 5. And then that means that our answer is going to be x equals to 1. For this one, the pronumeral is a. So we can multiply this, expand it out. So that's 14a plus 7 equals to 8. Now we look at the constant term, we want to get rid of it first, so we can subtract 7 from both sides. That's going to become 14a equals to 1. And that means that a is going to be 1 divided by 14. Now for this one, we can do the same, so pronumeral is x. So we're going to expand this out, that's 12x minus 4 times 2, which is 8. We're going to get rid of this minus 8 by adding 8 to both sides. So that's going to be 5 plus 8 is 13, such that x is going to be, now to get x, we divide both sides by 12. So that's 13 on 12. For the next one here, we're going to have, let's expand the left hand side first. 3x plus 6 plus 5x, 46. Now we can add these two terms together, so that becomes 8x. And then we can actually subtract 6 from both sides, such that we get rid of this 6 on here. So 46 minus 6 is 40. And now to get x, we divide both sides by 8. So this side becomes 1. 40 divided by 8 is actually 5. So that's our final answer. Alright, so let's look at this question here. B is the pronumeral, so we need to solve for B. So I reckon we could probably leave the left hand side as it is, but we can expand the right hand side. So that's going to be 6b plus 12. Now we have a choice of either moving 6b to this side or 5b to that side. Generally we want the pronumeral to remain positive, so we can subtract 5b from both sides. So this becomes minus 4 equals to b plus 12. And now to solve for b, we can subtract 12 from this side and that side. So this becomes b equals to minus 16. For this question here, we have a similar situation. We want to solve for a. So we could, in theory, just basically just expand each side. But then what we notice is we have a 2 here and a 2 there. They're both multiplying those factors inside the brackets. So what we can actually do is divide both sides by 2 so that these two cancel out. And then we're going to be left with a plus 5 on the left hand side equals to minus 2a minus 3. Now we can add 2a to both sides, so we get 3a on this side plus 5 equals minus 3. Now we can subtract 5 from both sides, so this becomes minus 8, 3a. And then in the end, we know that a is going to be minus 8 divided by 3. In this one, we're going to be solving for m, so let's see what we can do. Well, we could once again multiply it and expand, or we can actually divide both sides by 2. In this case, that would work because we notice 4 is a multiple of 2, 2 is a multiple of 2, so if we divide both sides, this one disappears, so we're left with 4m minus 5. 4 divided by 2 is 2m, and then we have 2 divided by 2 is 1. Now we could move this to that side by subtracting 2m from both sides, so that becomes 2m minus 5 equals to 1. And then let's see what else we can do here. So let's just bring this to this side. Okay, so we can add 5 to both sides, that's 2m equals to 6. And then divide both sides by 2, m is going to be equal to 3. And you can always check that by just plugging into the formula again and seeing whether the equation is satisfied. Alright, and this last question, what we're going to do is we're given an equation that has nothing but letters, but we're asked to solve for b. So we want to basically express this whole thing in terms, or basically have an expression for b in terms of everything else. So in order to get b, the first thing we could do is subtract d from both sides to get rid of this on that side. So we could get bx equals to ax minus d. And now what we can do is we can actually divide both sides of this equation by x. So this would be ax minus d divided by x. And we can expand this into two fractions. So this becomes ax divided by x minus d divided by x. And we notice from this one, the x is going to cancel out. So we're left with a minus d over x. And that's going to be our final answer. So hopefully this has given you a better idea of how to solve linear equations by using those techniques of manipulating algebraic expressions. And in the next video, we're going to do the same thing, but we're going to do it with inequalities.